Hey everyone, I want to pick up with where we left off in class on consumer choice theory. And so we were looking at a table of marginal utility from two different goods, from pizza and from Pepsi. And then in order to use the rule of equal marginal utility per dollar spent, we had to adjust by the price. And so we had divided a pizza by the price, which was the marginal utility from pizza divided by the price of pizza, which was $2. We got marginal utility per dollar. And then we did the same thing for Pepsi, but Pepsi only cost $1, so we could actually just work from the numbers in the table. And then we thought about our budget of $10 and how we would allocate that in order to get the most bang for our buck, or the most marginal utility per dollar. And I said, all right, well, what if there's a price change? Right? So what if the price of pizza went down to $1? I said, well, we would work from these same two columns, right? Because now if pizza is $1, then the marginal utility from a slice of pizza divided by 1 is going to give you the same thing, right? So let me get a different color going here. So now we still have $10 to spend, right? That part's the same, only now we changed the price, right? So pizza cost $1 per slice instead of $2. So we think of this as like the pizza happy hour. So now what are you going to do? What do you buy first? Well, which one gives you more bang for your buck? A slice of pizza for $1 would give you 20 units of happiness, and a Pepsi will give you 9. So the first thing you would buy, right, the biggest bang for your buck, is a slice of pizza. I spent $1. What am I going to buy next? Well, the second slice of pizza gives me 16 utils, or units of happiness. The first Pepsi only gives me 9, so I'm going to buy another slice of pizza. I spent $2. What next? Well, next up, another slice of pizza, right? Because 12 is greater than 9. So now I have 3 slices of pizza, and boy, am I thirsty. So what am I going to do next? Well, the fourth slice of pizza gives me 8 utils, or units of happiness. The first Pepsi gives me 9. So now, I'm finally going to get that drink, right? So now I've spent $4. I've had 3 slices of pizza, 1 can of Pepsi. What should I do next? Well, it doesn't matter. Both of them give me the same, right? The 8. So ultimately, I have enough money to do both. So now I've spent, $6? 4 slices of pizza and 2 Pepsis. What am I going to do next? Well, the next slice of pizza only gives me 4 units of happiness. So I'm going to buy a Pepsi, right? And now I've spent $7. And what's next? Well, another Pepsi. That's $8. And what's next? 1 more Pepsi, right? Because 5 is greater than 4. And then finally, what am I going to do with my last $1? Well, it's either a slice of pizza or a can of Pepsi. And it doesn't really matter. Now, in the model, according to the rule of equal marginal utility per dollar spent, let me write that a little neater. I'm not sure that's any neater. It's supposed to say or. According to the rule of equal marginal utility per dollar spent, if I could divide these into fractions, I would get half a slice of pizza and half a can of Pepsi, right? And the bang for my buck would be exactly the same from both. But since the pizza shop's probably not going to let me do that, then I'm either going to have 5 pizzas and 5 cans of Pepsi, or we'll pick a different color. I'll have 4 slices of pizza and 6 cans of Pepsi, right? It's one or the other. So it's either that last slice of pizza or the last Pepsi, one or the other. Now, that's why whenever we talked about the rule of equal marginal utility per dollar spent, I said across all the different things you consume, the bang for your buck should be about equal. And this is why, right? Because our consumption is lumpy. It's not continuous. We can't buy half a slice of pizza or a third of a can of Pepsi. So either we stop with the bang for our buck from pizza is 8 and the bang from our buck from Pepsi is 4, or we stop where the bang for our buck from pizza is 4 and the bang for our buck from Pepsi is 5, right? It's one or the other. But either way, the total utility you get from that combination, one of those two combinations, will be as big as you can, right? That total utility would be the same either way, and that's larger than any other total utility you could get from spending $10 on pizza and Pepsi, given those marginal utility numbers and the prices. So there you go. Think that through. If you have any questions, follow up in class. I'm going to move on and then talk about another topic here. What happens when the price of one of these goods change? So whenever you buy stuff, in our simple model where you're buying one of these two different things, what happens when the price changes? Well, two things happen. There are two separate effects to a price change. One of them is the substitution effect. And the substitution effect says basically when relative prices change, you buy more of the relatively cheaper thing and buy less of the relatively more expensive thing. So you substitute away from the now relatively more expensive thing and towards the relatively cheaper thing. So we're going to say buy more of the relatively cheaper good or service and less of the relatively more expensive good or service. So the substitution effect is fairly straightforward, and it says when the relative prices of something you buy change, you substitute away from something that's more expensive and towards something that is cheaper. Now, the one thing that we need to expand on here is what we mean by relatively more expensive or relatively cheaper. So we'll take a sidebar here on relative prices. So here you want to think opportunity cost. So initially, under our initial prices, right, and our pizza was $2 a slice and Pepsi was $1. So initially, the price of pizza was $2 and the price of Pepsi was $1. So then, what was the opportunity cost? So a slice of pizza, right? So the opportunity cost, every time I bought a slice of pizza, I gave up how many cans of Pepsi? I gave up 2 cans of Pepsi. Right, so the opportunity cost of one slice of pizza was 2 cans of Pepsi. And every time I bought a Pepsi, what was the opportunity cost of that Pepsi? The question is, how much pizza did I give up, right? The opportunity cost of Pepsi is some quantity of pizza. How much pizza? It was a half a slice of pizza. Everybody see that? So, and if you think opportunity cost, pizza used to cost me 2 cans of Pepsi, and Pepsi cost me a half a slice of pizza. Okay. Then, after the price change, delta for change, right? So what we called pizza happy hour. During that time, the price of pizza was $1 and the price of Pepsi was $1. So in nominal terms, right, the price change was right here. Price of pizza went from $2 to $1. And in nominal terms, there was no change in the price of Pepsi, right? Pepsi was $1 before, Pepsi's $1 now. So in nominal prices, the price of Pepsi didn't change. The nominal price of Pepsi is the same. The nominal price of pizza went down. But what about the relative price? So let's think here in terms of relative price. Think about the opportunity cost. The opportunity cost of a slice of pizza during happy hour, right, or after the price change is what? how many cans of Pepsi? Now it's only 1 can of Pepsi. Right? Because if pizza is $1 and Pepsi is $1, then every time you have a slice of pizza, you give up exactly 1 can of Pepsi. And it works the other way too. If every time you drink a Pepsi, you give up how many slices of pizza? Just the 1. 1 slice of pizza. So now what's that mean in terms of relative prices? Well, initially, a slice of pizza used to cost me 2 cans of Pepsi, and now it only costs me 1 can of Pepsi. So in relative terms, the relative price of pizza has gone down. Now that doesn't surprise us, right? Because the nominal price went from $2 to $1. And so if the nominal price went from $2 to $1, and now we can also see the relative price went from 2 cans of Pepsi to 1 can of Pepsi. So that's probably not all that surprising. But here's the part you have to pay attention for. What color should we use for this? We use the darker purple. Initially, every time we drank a Pepsi, we gave up a half a slice of pizza. And now, when we drink a Pepsi, we give up a full slice of pizza. So what happened to the relative price? Well, the relative price of Pepsi has gone from a half a slice of pizza to a whole slice of pizza. That's up. And this is the part you have to pay attention for. The relative price of Pepsi has gone up, even though Pepsi used to cost $1 and now it costs $1. So in nominal terms, it hasn't changed. But because the price of pizza changed, the opportunity cost of Pepsi has changed as well. So you have to be alert and say, yeah, you know what? Even though Pepsi used to cost $1 and Pepsi still costs $1, Pepsi cost me more pizza than it used to because the nominal price of pizza went down. So in our example, pizza has gotten cheaper and Pepsi has actually gotten more expensive, right? So if you go back up to our definition of the substitution effect, buy more of the relatively cheaper good and buy less of the relatively more expensive good. So in our example, this is saying, hey, eat more pizza, but step back from the Pepsi, right? Don't have as much Pepsi. So the substitution effect is telling you, enjoy the pizza, have more pizza, but stay away from the Pepsi. Does everybody see that? It's sort of a silly question to ask in a video, isn't it? If you don't get that, think it through. Look at the book, shoot me an email, come to office hours, right? We'll bring the question to class on Wednesday. We'll work through this. But that's the substitution effect. So it has to do with relative price. Think opportunity cost. All right, the income effect. The income effect has to do with the overall purchasing power or your effective wealth whenever the price of something you buy regularly changes. So if price of something I buy goes down, now I'm going to leave a little room because I'm going to put in the other directional description as well. But if the price of something I buy goes down, I feel effectively, here's where we're going to have room for 2 different things as well, richer, and I can buy more of all normal goods. Remember normal and inferior goods? Normal goods are things that as your income goes up, you buy more of them. As you're effectively wealthier, you buy more of them. So if the price of something I buy goes down, I feel effectively richer and I can buy more of all normal goods. So the best way to think about this in my life experience is with the price of gas. We know that from when we talked about elasticity, that demand for gasoline in the short run tends to be fairly inelastic. Right? If the price of gas goes up, we may find small ways to cut back, but for the most part, we use just about as much gas as we did before. We still drive to work, we still drive to school, right? We still run errands. So if the price of gas goes down, we notice that. We're like, hey, I feel richer, right? I feel effectively, I have more discretionary, more purchasing power. And so what happens? Well, maybe we go out to eat or get takeout, a little bit more often. Maybe we indulge in, new shoes or clothes or something. Why? Because we feel effectively richer because we're spending less on gas. And of course, it works the other way too. Let's fill it in the other direction. Still need something light colored here. We'll use this one. If the price of something I buy goes up, I feel effectively poorer, right? When the price of gas goes up, if gas is now, say $3 a gallon, if the price of gas goes up to $4.25 a gallon, that pinches, right? A lot of us notice that. And then what happens? You feel effectively poor, right? A household that has a certain amount of driving to do may feel effectively poor, and they may buy less of a lot of normal goods. So in that case, maybe they eat out less. Maybe they don't, and again, maybe we're not eating out or going to the movies that much right now, but we don't pay for, brand new movies from Amazon Prime, or we don't order takeout, or we just don't buy, something that we were looking forward to, whether it's new shoes or new clothes or neon lights for under your car. I don't know, whatever that purchase was that you might be interested in. That's a normal good, such that when you're effectively richer, you buy more of it. And when you're effectively poorer, you buy less. The price of gas goes up, we buy less of all the good things. So what does that mean in our particular example here? Well, in our example here with pizza and Pepsi, if the price of pizza, right? So when the price of pizza goes down, we feel effectively richer. When it's Thursday night and we're out at the pizza shop with our friends with $10 in our pocket, if the prices are $1 for pizza and $1 for Pepsi, we feel effectively richer than if the prices are $2 for pizza and $1 for Pepsi, right? We're effectively richer, right? The money in our pocket, our budget for eating out goes farther, and we can enjoy more of all normal goods. So the income effect says, hey, pizza is cheaper. Enjoy more pizza. Enjoy more Pepsi, right? Have more of both. The income effect in this case is saying you can have more pizza and more Pepsi because they're both normal goods. They're both things that you like. And as your income goes up, you could buy more of them. So effectively, your income has gone up. You're effectively richer. So the income effect is telling you have more pizza and have more Pepsi. Meanwhile, remember the substitution effect? The substitution effect was saying, hey, have more pizza, but whoa, Pepsi is relatively more expensive, right? Stay away from the Pepsi. So the way I think about this, these are two separate effects. They're both happening. And I think about them this way. This is I've never tried to draw it like this, but I need somebody with broad shoulders here, right? So there's a person, and the reason he needed such broad shoulders is, the cartoons where there's an angel on one shoulder and a devil on the other, and it's always, you have this do the right thing, do the fun thing sort of thing going on in your mind, and the angel and the devil represent those two perspectives. It's not inherently good or bad, but I think of it as having these two little birds on your shoulder. And I'm not really an artist, so I'm not sure how to draw the bird here. Hey, that was actually better than I expected. So you have two birds on your shoulder. One is the income effect and one is the substitution effect. One is not inherently good and one is not inherently bad, but they're telling you two different things, right? So the substitution effect is whispering in your ear, have more pizza, but stay away from the Pepsi. And the income effect is saying, hey, you're effectively richer, have more of both. So what do? Well, it really depends on the magnitude of those two effects. And so we can look and see for the individual we were talking about in this example here, who had these particular marginal utility numbers, we can see that, did they have more pizza? Well, initially, we would have, right, the first time when pizza was $2 a slice, we had 3 slices of pizza, right? And 1, 2, 3, 4, is that right? Yeah, 3 slices of pizza and 4 cans of Pepsi. But then when the price changed and everything was $1, we had 1, 2, 3, 4, either 4 or 5 pizzas, and then either 1, 2, 3, 4, 5, or 6 Pepsis. So remember before we had 3 and 4. So if we just sketch in that, if we used to, whoops, that's not what I wanted. I wanted to change this color. Initially, we would have stopped at 3 and 4. So what happens? We have either 1 or 2 more slices of pizza and 1 or 2 more cans of Pepsi. So for this individual, when the prices changed, they had more of both. Does that mean there was no substitution effect? No, it just means that the income effect was stronger, right? The income effect was more powerful than the substitution effect in this particular instance. Why? Because they had more of both. The substitution effect said, right, have more pizza but less Pepsi. And so at the end of the day, we saw that this individual had more of both, which means the income effect overpowered the substitution effect. So those are the two effects. They don't always, it depends on which way the prices are changing to determine which direction they would push in. But if you understand the effects, you can think through the implications. So what's important about consumer choice theory? What can we understand with it? Well, lots of things. Why are newspapers and sodas and snacks sold in different kinds of machines? Now, I realize there's not a lot of newspaper vending machines out there anymore, but hopefully you recognize them. And if you know how they work, you put your money in and that unlocks the door. You open the door and then you grab a paper off the stack, right? Could you steal, could you take more than one newspaper? You could. What about with the vending machine for candy? Is that how it works? You put in your money, it lets you open the door, and then you grab the candy bar you want and leave? No, they very carefully dish out just one at a time. So why is that? It's almost like they trust newspaper readers more than people who eat candy and snacks. So is it the case that people who read newspapers are inherently honest and people who eat snacks are not? No, I don't think so. How would you explain this difference? I think the difference in these two vending machines can be explained a lot by diminishing marginal utility, right? To the extent you find the first newspaper useful, how valuable is the second newspaper? Not so much, right? The second newspaper, it's just another copy of the first one. It's not really that useful. I mean, unless you're puppy training or something and have need for a lot of newspaper, it's not very valuable, right? Diminishing marginal utility sets in hard after one newspaper. But pick something out of this vending machine. What do you like out of here? I don't know. Snickers, M&Ms, that looks pretty good. Any pretzels up here? I'm always a sucker for the pretzels. So pick out whatever you like out of this vending machine. Diminishing marginal utility says the first one is probably the most valuable. The second one maybe not quite as great as the first, but it doesn't drop off like it does with the newspapers, does it? So maybe the cost benefit, this machine is probably a lot more expensive to build than this one, right? This is very simple, but maybe that's all they need with newspapers because the second newspaper is not that valuable and there's not a lot of incentive to steal it. What else can we explain with this? Diminishing marginal utility, this is also huge when you think about Seabreeze has this passport program, right, where you can get basically a season pass. And the season pass is a surprisingly low multiple of a single admission price. So whatever the single admission price is, the season pass might only cost, I don't know, 5 or 6 of those, right? 4 or 5. And so theoretically you could, I mean, if you went 4 or 5 times a week all summer, you could get a great deal, right, with that season pass. And I'm sure that there are individuals and that there are families who take advantage of that. But even if you have the season pass, do you go to the amusement park 3 or 4 or 5 times a week all summer long? I don't know. Why not? Diminishing margin of utility again, right? What about all you can eat buffets, right? How do they ever make any money? Like, how do they, how does an all you can eat buffet, make sense? Well, they can do that because even though we might eat more at the all you can eat buffet than we would when you pay, per plate, per piece, per menu item, most people are really not going to eat all that much, right? Why? Because of diminishing margin of utility. So these are important concepts, and they really help us. There's a lot that we can do with consumer choice theory. And then if you go on and take more economics classes, these concepts will come up, again and again. So there you go. That sort of wraps up chapter 16 on consumer choice theory. Think it over, read the book, bring your questions in, and we'll catch up soon.